So here we discuss an numerical to find eigenvalues and eigenvectors. The question is, we are given a matrix and question is to find eigenvalues and eigenvectors. So we start by finding characteristic equation, that is determinant of ti minus a equal to 0. So this is our a. So putting a here, and I is the identity matrix of order 3 cross 3. So it becomes t minus 2 times t minus 2 minus 1 t minus 2, which imply t minus 2 t minus 2 square minus 1. So applying a square minus b square here, t minus 2 t minus 3 t minus 1 imply t is 1 2 3, which are the eigenvalues of a. Now to find eigenvector associated with t is equal to 1. So putting t is equal to 1 in ti minus a x equal to 0 matrix, where x is x, y, z, eigenvector associated with the eigenvalue t is equal to 1. So putting these value here, that is 1 0 0 0 1 0 0 0 1 minus 2 0 1 0 2 0 1 0 2 x y z. So this we are left with minus 1 0 minus 1 0 minus 1 0 minus 1 0 minus 1 times x y z. So multiplying these two matrices, we get minus x minus z equal to 0, which further imply z is equal to minus x. And from second term we get minus 5 equal to 0, which imply y equal to 0. And from the third term we get minus x minus z equal to 0, which is again z is equal to minus x. Now to get the eigenvector, we rewrite eigenvector x, y, z, and substituting the value x as x, y as 0, z as minus x, which is 1 0 minus 1 over x. So 1 0 minus 1 is eigenvector corresponding to t is equal to, which comes out to be 0 0 0. So again multiplying minus x equal to 0 and minus z equal to 0, which imply x as well as z equal to 0, and y can take any value. So the eigenvector is x y z equals 0 y 0 which is 0 1 0 y. So the answer is 0 1 0 is eigenvector corresponding to t is equal to 2. Now third part, for t is equal to 3, again putting t is equal to 3 in ti minus a x equal to 0. Here again x is a column vector x y z. So after substituting x minus z equal to 0, y equal to 0, minus x plus z equal to 0, which again imply x is equal to z, y equal to 0. So the eigenvector is x y z x 0 x, that is 1 0 1 times x. So 1 0 1 is the eigenvector for t is equal to 3. Hence the eigenbasis is 1 0 minus 1 0 1 0 1 0. To find eigenvalues and eigenvectors of a linear operator defined by this. So here first of all we will convert this transformation into a matrix using the basis, and we will write matrix relative to basis. That we know, to write this we take t image of these elements and then again express the image as linear combination of these elements. That is this way. So putting 1 0 0 in the transformation, 1 0 0, which is 1 times first element, 0 times second, 0 times third. As we know that matrix relative to the basis is transpose of the coefficient matrix, that is 1 1 1 0 2 1 0 2 3, so which is the required A. Now we proceed in the similar manner as we have done for a matrix. So we again find the characteristic equation by finding the determinant of this. That comes out to be t minus 1 minus 1 minus 1 0, t minus 2 minus 1 0 minus 2, t minus 3 equal to 0. So taking determinant by column 1, we have t minus 1 times t minus 2 minus 1 minus 2, t minus 3 equal to 0. So again solving, t minus 1, t minus 4, t minus 1, which imply t is 1 1 4. So this further imply t is equal to 1 and 4 are two eigenvalues of t. To find eigenvector of t is equal to 1, to putting t is equal to 1 in ti minus a over x is equal to 0, where x is the eigenvector and 0 is the 0 vector. So putting t is equal to 1, I identity, a the matrix we have found, so we get 0 0 0 0 0 0 x y z equals 0 0 0, which further imply minus y minus z equal to 0, which imply y is equal to minus z. So the corresponding eigenvector is x y z equals, x can take any value, let it be y, y and minus y. So it comes out to be 1 1 minus 1 times y. So 1 1 minus 1 is eigenvector corresponding to t is equal to 1. So similarly we will find eigenvector for t is equal to 4. So putting t is equal to 4 in ti minus a times x equal to 0, we get 3 minus 1 minus 1 0 2 minus 1 0 minus 2 1 times x as eigenvector and 0 vector. So again operating r3 plus r2 will give 0 2 minus 1 0 0 0 x y z 0 0 0. Multiplying this matrix we get 3x minus y minus z is equal to 0 and 2y minus z is equal to 0. So simplifying these two we get 3x minus y equal to z, and from here we get 2y is equal to z, and further simplifying these two we get x is equal to y and z is equal to 2y. So the corresponding eigenvector is x y z y y 2y, that is 1 1 2 times y. So the eigenvector is 1 1 2 is eigenvector corresponding to t is equal to 4, hence the answer.